Okay guys, it's 15:45, so it means we are starting. So, well, it's my first time in Riga and I really like the city, and thank you very much for inviting me here. As you can see, after my talk was announced, you could probably see that the name was slightly different. It was called the JavaSlang, Functional Java Done Right. But actually recently it changed its name to Vavr, Functional Java Done Right. There is a short story associated with this. Basically, the project I will be talking about today was used to known as JavaSlang. But as you probably know, putting Java in the names of anything is very adventurous case, because that eventually Oracle gets you. So same happened to JavaSlang after 3 years, and suddenly the name needed to be changed. So once Daniel Dietrich, the main creator of the library, closed his laptop with stickers on it, and noticed that basically if you turn around the sticker, it looks like VAVR, Vavr. And this is how the word name got from. The nice thing about that is, well, that you basically could recycle all existing stickers, because you could just cut off the Vavr part out of it. Well, I had my own proposal. Well, my proposal was lalalang. This can be also engineered from the stickers, but for some reason no one treated me seriously. I have no idea why this could be. So basically, I'm a software developer. Don't want to say that I'm a Java developer, because I try to write in every possible languages, but it turns out that basically, well, the JVM is like my main weapon of choice. I work in a very progressive software house in Poland. Besides this, I'm a UU player, so if you ever try to Google this presentation or something, you might find some weird UU stuff. Yes, that's me. And I used to be a musician too. Anyway, if you ever want to find me, you have this Piwowarek Twitter handle, GitHub handle, LinkedIn handle, and handle to probably some sites that I should not mention publicly. So basically, if you want, everywhere is the same, including slides.com, where you'll be able to find those slides. So, let's get to the talk. So, Java 8 was a very special release. Firstly, because we've been waiting a very long time for it. Okay, it was quite a lot of years. And the other thing was that there was a promise of bringing new tools to Java, tools known from the world of functional programming. Well, so it was supposed to be lambdas, optionals, and other stuff. So for Java, it was a very big revolution, because Java was a very fundamentalistic OOP, and suddenly, well, you could also notice multiple times that Java developers were kind of opposing the functional programming. Okay? This is just keep this stuff away from Java. So when eventually the stuff was introducing to Java, it was a big revolution. Well, some people didn't like it. Most of people were excited, and they were even calling this release like that it was functional. That's not Java 8, it's functional Java now. Well, but after it was released, people started actually seeing that, well, okay, we have this functional Java, but how much functionness is in Java now? Well, we have lambda expressions, which is basically, well, a new syntax for anonymous inner classes. Well, after compilation changes, it differs a bit, but most or less you could be able to do the same stuff in previous versions of Java. Well, when we were creating threads or stuff, you would not pass a lambda, but you would pass an anonymous inner class instead. Well, it works pretty similarly. The other thing is that we got optional, stream, compatible features, all those monadic type of tools. But besides this, there was not that much stuff. Okay, so functional Java. Well, people noticed that this word is kind of, well, too big to call this actual release, this particular set of changes that were brought to Java. Some people started noticing also that some very simple operations were, well, we managed to avoid quite a lot of boilerplate, but the new tools were still quite boilerplatey when it comes to very simple operations, like, for example, well, mapping through a collection. So as time passed by, people started noticing more and more lacks of Java 8. So the first thing is that we got only 3 functional control structures. We got optionals, streams, completable features, but other languages like Scala, for example, there are many more tools that could have been introduced. Okay. The other thing is there was no concept of memoization introduced. One side note: if you have no idea what those words mean, just stay with me. There was no lifting for functions, no pattern matching, which is super useful thing when it comes to writing code in a functional world. No tuples. After so many years, we still don't have tuples, and we are forced basically to use something that we write by ourselves or just find on GitHub. There are so many tuple libraries on GitHub. Another thing is people didn't like some design choices made with optionals, for example. Optionals, for some reason, were not serializable nor iterable. Well, the explanation that I found out during DevOps is basically that it was not intended to be serializable. But, well, it's a very good answer, but not very satisfying, okay, because it could make so many things easier. But honestly, the biggest problem for me was that we got new tools, optionals, streams, but Java needs to be backward compatible. And it creates problems, because we have already existing APIs that, for example, return nulls instead of optionals, and we have new APIs that return optionals. So there is some inconsistency over there, and it's very easy to get confused when using new methods and old methods. Well, and still there were much more spots where you could actually where streams or optionals could have been used to make things easier. Another thing is, have you ever tried like throwing checked exceptions or handling checked exceptions inside of a lambda function? I see people smiling, so yeah. This is super painful because I don't know if you realize, but if you have functional interfaces in Java, all those function representations, they don't have throws clause in their signature. And this is a problem, because when suddenly you end up having a function that throws an exception, you need to manually, by hand, just try catch it in a body, and either usually just swipe it under the carpet by ignoring, or just repackage it into a runtime exception. So this is super cumbersome. Another thing is, people started complaining about type pollution. If you go into Java util function package, you will see that you have now function, by function, predicate, consumer, by predicate, unary operator, binary operators, and many different forms for representing a function. And for example, for me, it was super confusing at the beginning, because I was playing with Stream API, and for some reason, sometimes they were not asking for function, they were asking for consumer and asking for predicate, binary operator, and it was a huge problem for me. But eventually I got there, but it took some time. But why not just use fewer types to represent what's at the end of the day a function? The other thing is, if you have functions of different arities, so for example, you have function by function, well, in Java you have only like it goes up to arity of 2. But imagine a situation if you needed to go to the arity of 10, for example. So okay, so let's count: function by function, try function, quad function. And this is the moment where my English breaks. So it's not that intuitive at that point. The other thing is, that all those new introduced features were still quite boilerplatey. Well, probably there were many more other examples, but let's focus on those. But before we go into actual waiver talk, let's have a look at this function signature. Let's just spend a second, take a deep breath, and close your eyes and just think, what do you see? Okay, we all see here a list of parameters, list of return values, and some name. So let's have a think for a second what can be inside. Okay, I can hear that some people are taking very deep breaths. So, okay, so I closed my eyes and I wrote that function. I wrote the implementation, and as you can see, I did a lot of very, very bad stuff. Because as you can see what's happening over there, well, when you were looking at the name of the function, inputs, outputs, you had some intuition. You were thinking, oh, maybe I'm not doing anything, maybe adding another element into this, or maybe, well, doing something pretty simple. But in Java, we can do very evil stuff. So as you can see here, what I made here is, for example, the result of the function does not depend only on the input. It depends also on some internal state of this object. It depends on the external state. It depends on the moon phase. And basically on many different unpredictable stuff that you would never think of when reading the method title. It also modifies the state of the object and modifies the external state. It can also throw exceptions, which can be also thought as another exit point of the function. Okay, so whenever you're writing functions and have inputs, outputs, as you can see, many unexplainable, unintuitive stuff can happen. So generally, we have a situation where we have, for example, instance state, global state. If they all can somehow influence the output of our functions, they should be considered inputs, okay? They should be mentioned somewhere, okay? So in order to set proper expectations. But instead, we have all those crazy things. And now imagine you have a function that accepts, well, one param, changes local state, changes the global state, but this change of the local state influences another function where it's not explicitly defined. Okay, and this changes another one. It modifies global state, which influences another function, and this one throws an exception. And then we are 2 days later, the moon phase is different, and we end up in a mess. Good luck debugging this. So this is super problematic, especially if your language allows you to write code like this. But in functional programming world, we strive for the situation where we have only where the input and output are directly related to each other. So if you have, so only output can only be the result of something done with the input and any other stuff. It shouldn't do any side effects, accept stuff out of nowhere on depend or any other changeable state. And here we come to one thought that I'd like to remind everyone of, because I see that there is some common misconception that the presence of lambdas is also, it can be something that defines the functionness of the language. And this could not be further from the truth. Because lambdas are just a nice way of passing behavior around. But this doesn't make your language functional. It doesn't mean you are writing functional code. You still can be writing imperative code, passing lambdas around. So basically, it's very hard. If you try to Google the definition of functional programming, you can't find like the very one that you could depend on. But I found one that I'd like to focus during this talk, which is functional programming is about writing pure functions, about removing hidden inputs and outputs as far as we can, so that as much of our code as possible just describes the relationship between inputs and outputs. When we code like this, we build our solution from usually small blocks that are predictable, easy to understand, and when you build your solutions from small blocks that work, usually the whole thing works. Well, more often than if you build your stuff from very unpredictable building blocks that when you combine stuff together, it just explodes, okay, as in a butterfly effect. In order to write better code, we can focus on two things. We can focus on immutability and referential transparency. Immutability, well, it's pretty intuitive. It means that if you create an object, you can't modify it afterwards. So what to do if you can't modify it? Well, obviously you can create a copy that holds a modification of the internal object. The other concept is referential transparency, which means basically when we have some functions or methods, and if we call this method with a particular set of parameters, and you get some result, and you call it again, you should always get the same result without any side effects. And it doesn't matter what weather is outside, what moon phase is, you should always get the same result. So those are very important building blocks of functional programming. And here comes another misconception, because if you go somewhere over the internet, you will be able to see that there are many people arguing, well, about like OOP versus functional, why functional doesn't make sense because it doesn't apply to real world, and so on and so on. Well, functional programming doesn't force you, well, doesn't get rid of side effects and mutability, because this is how our world is constructed. By applying some higher abstractions, we can pretty much even out the problems that dealing with mutability and side effects cause. So this is for me why it's worth doing it. Another thing is that, well, if you want to write code in functional style, because you see, immutability, referential transparency, those are some limitations, those are some constraints that we need to follow. And it might be harder than just writing simple mutable code with side effects. Well, I treat it as a form of investment, okay? This code is slightly harder to write, especially after you change your mindset, start thinking a different way. But after you do this, you invest into your code base that becomes more maintainable and usually works often. It plays out well in a long term. So you can write functional code without lambdas. We've been doing this with anonymous inner classes and using Guava, for example. But it's very hard to code in a functional manner if you don't have the right tools for the job. Well, let's have a look at the collections API. So, if you want to you play with immutable structures, you need to create copies. So, let's have a look at the, for example, add, remove, or clear methods from collections API. What do they return? They return void, they return boolean, they return integers, for example, like representing the index of the element in a collection or something like this, but never it's a copy, a modified copy. And if your language, one of the main building blocks is, well, that makes it very hard to program in such a way, it becomes super difficult, okay? Because other libraries are using collections API. It's super hard to integrate with them. Well, there were some tries. I mean, in Guava you have immutable collections, well, immutable views on collections. But do you know what happens when you call add or remove on something like this? It doesn't, of course, it can't return a copy because you have something else in the interface. But it throws an exception that, well, no such operation is possible or something like this, which is super uncomfortable, okay, to use. So, and the other thing is that if you deal with immutability, you can perform some kind of optimization. For example, if you create your object, you can recalculate the hash, store it instead, and it opens quite a lot of possibilities for you. And you will never face problems like this, very common one. Imagine that you have a hash map or hash set, you put some value, some object instead, and then you modify it outside that map. If you modify that object, its state changes, its hash changes. So whenever you try to go back and look into that map, it's not there, according to this. We lost the identity of that object. And many, many more problems like this can be, for example, avoided by using, well, immutability. Yeah, and this is worth fighting for. So this is where Vavr comes into play. Vavr is basically all of this that you can see there. Well, probably you can't, but quite a lot of it. Basically, there are three main building blocks. There is a new set of functional interfaces. There are tuples. New redefined, redesigned collections API for Java, Many tools like match, lazy, option, try, so not only free functional control structures, but much more of them, and the basic form of pattern matching. So we'll now go through all of them and see some examples. So first thing, when it comes to the functional interfaces, it works pretty similar to what you can find in Java. But we got predictable names, functional interfaces that go up to the arity of 8, and plus some nice new features. So as you can see here, everything is, well, looks pretty like in Java, but as you can see here, we have this number 2, which represents the arity of the function. So whenever you are looking, for example, for a function that has 7 parameters, you go to function 7, okay, and not queen function or some queen, I don't know. So that's super predictable, it's super intuitive to use. The other thing is, remember the problem with checked exceptions in lambdas? Well, for every set of functional interfaces here, you get another functional interface, checked interface, that has the exception in the method signature. So whenever you want to handle some exceptions in lambdas, it's much easier using those predefined functional interfaces. You also have some very useful utility methods that allow like automatic conversion between checked and normal one. So for example, you have methods that allow you to change checked function into a function by, for example, automatically repackaging checked exception into a runtime exception. So we can of course compose them just like in Java. We can perform function lifting. This is super useful concept. Remember situation on the slide, like that was a few slides ago, with list of possible outputs that function have? Well, one of the possible outputs should be considered an exception. Well, this is how it works in maths. Okay, you have set of inputs. You have some values from some of them, but it's not like you get an exception if you try to call your function with something that it's not defined. Okay, so we can basically change the signature of the function by perform lifting. If you lift your function from a partial to a total one, the result of the method changes to an optional, and this is how you can, well, you end up with a function that doesn't throw any exceptions, but returns an optional that holds your value or not. The other nice thing is that all those functional interfaces support currying, which we'll get to it in a second, and my favorite tool, all of it, memoization. So here, let's have a look at the lifting example. We have a functional interface that, well, makes a division of two numbers, and as we know, division by 0 is a very bad thing to do. Don't do this. So obviously, this will throw an exception if we pass 0 as b. By performing lifting, we can change that function to something that will never throw an exception. But as you can see here, as a result, you don't have an integer anymore. You have option of integers, because either you can have a result for a particular input or not. No exception, but we have optional. Sometimes we don't care about actual exception, but we care only if we got a value or not. The other quite useful thing is carrying. Well, if you model your domain using a lot of abstractions, when you have a lot of functions, sometimes in a situation where you would actually try to reuse already existing function, for example, by fixing one of the parameters, by providing the same value always. So if you represent your function in a slightly different way, by performing carrying, you can leverage partial application in an easy way. So what's happening when we apply carrying to that function? As you can see, on the above example, we have function 2 with the arity of 2, and on the below, we have function 1. Well, as you can see, we got rid of some parameters. And instead, as you can see, we are returning another function instead of a direct result. It means that we can perform, and now, if we have such representation, we can perform application one by one. So let's try to do this. So we have this carried version. We can apply, well, we can call that method with 2, and instead we get a new function. In this case, it will be a function that, well, changed from summing of 2 integers to a function that adds 2. Well, so you can see we pretty much fixed one parameter once and for all. My favorite tool is memorization. Well, as I told you, one of the building blocks of functional programming is referential transparency. Well, so actually, if we call a function with a certain set of parameters, we expect always get same results. So why actually bother with recalculating, well, the same value all the time if we know that it will be exactly the same value? Well, let's just cache it. Well, and this can be done. Okay, you have a if you want your function to perform caching of the results, it's very easy to do because you have instance method memorized, and this is ready to go. Actually, I have a very bad example to show that it works. Do you know method mathRandom? Probably all of you do. It's totally the opposite of what we should consider referential transparent. But let's break it. So as you can see here, we are creating a function that returns, well, random results, and we memorize it, which means we are breaking it, because after calling it once, the result will get stored into internal cache, and in every future call will get returned from that cache. So as you can see here, we broke the mathRandom function using this. Let's go further to tuples. Well, if you don't know what a tuple is like a very lightweight idea of anonymous typed object. Well, it might sound scary, but sometimes actually you need to like group few objects together. For example, if you want to return more than one value, or for example, when you are zipping 2 streams, 2 collections together. Well, how do you represent the zipped pairs? Okay, you need to create your own pair, or just use a tuple that's already predefined. In Java, you need to write your own pair, or just map entry, which is super uncomfortable to use. So as you can see, it's very easy to create such instances because you have a static factory method of that accepts some parameters, and then you have a tuple. Of course, it's immutable as pretty much everything in JavaSlang. Oh, sorry, Vavr. And now you can leverage a very nice APIs known basically from the whole functional world. So you have map, flat map, transform, and even such crazy method as to sequence. Well, it might be useful sometimes. So, but now the most useful part of JavaSlang is the mighty interface of value that represents the functional value, a container that can hold some information or not. And if you look at the subclasses, you will see that there is an option which works pretty similarly to optional known from Java, but it's on steroids. You have try, which is a nice tool for dealing with exceptions. We'll have a look in a second. We have a lazy, which will allow us to work on a lazily initialized values. We have either, which allows us to hold element of which can be of one type or another. A future, which works pretty similarly to what we have in Java as completable future. Validation monad, well, validation which allows you to perform a very nice, easy way of doing validations on objects. And what's super interesting is if you have a look at if you go up in the type hierarchy, you will see that at some point value extends iterable. This is because this is a container with values, and if you have a value or not, you can think of it as a form of a collection that has 0 or 1 element. It can be very useful in certain spots where we will be leveraging polymorphisms heavily. What's also super important that the whole new collections API also extends iterable. So this is the way how we can achieve interoperability with Java. So the common denominator is iterable. Another thing that will be introduced soon in JavaSlang, Vavr, is a collection views. You will be able to transform your collections into something that implements the collections API interfaces, which will pretty much just delegate the operations to the underlying collection without repackaging everything. So option works just like optional, as you can see. We put something inside, and we don't need to care if it's nullable or not. We just express our will declaratively. We provide functions that should be applied to what's inside, and at the end we just return a default value. Well, specify a default value. But have you ever tried did you ever have like a stream of optionals and try to like extract only those that are inside? Well, as you can see, it's possible. It's not super hard, but it's still quite imperative. Well, you need to take a stream, you need to filter out all present optionals, then like extract values manually, and then collect to list. It's quite a lot of operations. But now, if you want to, we can leverage polymorphism, okay? Because if you know that your optionals, tries, or other tools are iterables, you can perform a flatmap operation, which means you can automatically treat them as collections and collapse them, okay? So if you have an empty optional, it's nothing. So you collapse it to a nothing. And if you have an optional without an element, you collapse it to 1. If you were working with normal collections and perform the flatmap operation, for example, if you have n elements, it would just be collapsed to n elements and flattened. So as you can see, can be much easier. Another nice, very useful tool is try. And actually, if you like this concept, I'm working on a new talk dedicated just to like dealing with exceptions in a functional manner. So definitely, I hope I'll be here next year. So it works similarly to an optional, but now you can deal with exceptions in a nice and declarative manner. So you put some values inside, well, in some case, some actions that can produce exceptions, and now you can leverage all this nice functional API like map, flat maps, filter for dealing all of them. Of course, you have some, exception-specific methods like recover, or get or try, or so on. So of course the API is very rich and allows you to deal with exceptions in a very nice way. Obviously, if the exception was thrown, you can specify the default value, similarly to the optional. Lazy, this is the way in which you can deal with lazily initialized values. It shares the same API. You have maps, flat maps, filters, and so it's pretty intuitive to use, pretty consistent among the whole like JavaSlang and Vavr and other basically functional languages, because it doesn't matter if you go to Scala, if you go to other languages, you will still find the same concept of maps, flat maps, filters all over again. So let's have a look. Now we are using static factory method of. Well, we are putting a very long computation inside, and now we are specifying declaratively, toString and toUpperCase. But this is just an expression of our will. We are not actually doing anything to the object. But when we actually want to reach that value, we call .get method, and this is where actually the method is called. Then on this result will be toString applied, and then toUpperCase. So super useful. And now the most interesting part is the functional data structures. How many of you have seen today's talk of Oleg Shilayev? Oh, almost everyone. Great. Well, so you probably know something about it, but for you that have not been there, there is some problem, okay? We already know that immutability can be beneficial, but imagine a situation where you have a collection, and you want to add a million elements to it. Well, if you would be adding it one by one, you would need to create a lot of copies, okay? Because every addition would create another copy, which is not super efficient. So it forced generally to redesign, to think in a different way about collections. And people came up with a recursive concept for collections, where you pretty much don't literally copy everything, but rather reuse what you already have. So this is what Oleg was talking about. And well, definitely check his talk up because he talked about 1 hour about those concepts and explains them really well. I visited this talk 3 times. It's super interesting, and he makes funny jokes. Okay, so now if you have a look at the type hierarchy of the sequence in JavaSlang, you will see that you have like stuff that you probably already know, like array, vector, stack, list, stream, and queue. But one of those elements doesn't really fit in there. Can you tell me which one? This one. Look, because what's a stream in Java 8? It's not a collection. It's rather a very funky way of, well, of an iterator. But in a normal like functional, well, it was some kind of trade-off that they introduced in a Java design. But in a normal functional world, streams can be thought as a normal collections, well, presentations of sequences. In Java 8, you had problems because they would be, for example, you could not reuse them. Okay, so and now they are fully reusable. So it's important to remember that whenever you find a stream, it's something else that you did not find in Java. And now the most interesting part. Well, if you go to Tuples, all those functional interfaces, or all those persistent functional data structures, and use code completion tool of your IDE, you will be like overwhelmed with all possible methods. I remember that I was overwhelmed when playing with Java 8 at the beginning, but after some time I started noticing that some methods are clearly missing there. Have you ever missed any method in particular from Stream API? No? No? Oh yeah, some people are nodding. REST is REST got everything they ever needed from Stream API. So basically, in JavaSlang, well, you have all those methods you missed. I, for example, missed the distinct method where you could specify, for example, well, your own comparator or equals method. That would be super useful. Well, have you tried adding one element to a Java stream? Well, super uncomfortable because you need to pretty much create a new stream and concat 2 together. Well, here everything is possible. Okay, so whenever operations like append, create a cycle where you can take a stream and just infinite stream and make it infinite by repeating it all over again. Okay, you have distinct by interspears. You can drop from the left, drop from the right. You can filter. You can zip to streams or to collections together. Well, easily add another element to stream, or even do some nice things like creating streams with cross product, the result of a cross product of all elements in a collection. So that's super useful. And if you ever feel like you are missing something, just go on GitHub and start an issue, and soon it will be there. Or guys will just very politely explain you why it won't be there. So, for example, you can create such a nice stuff like here. This is a Fibonacci sequence implementation done in a recursive functional way. Don't expect me to explain that to you, well, but you can still impress your girlfriends, boyfriends, parents, teachers, whoever you want. Anyway, the final thing that I'd like to talk about is pattern matching that was implemented in JavaSlang. It's, of course, well, it's not the pattern matching implemented on a language level. It's like a homemade stuff, but still can be useful in certain situations. Basically, pattern matching is an advanced form of a switch case. In Java, you are limited to few types, but here you can pretty much use predicates. You can use the whole object, and even you can refer to only a part of the object structure. So as you can see here, we have match, we have 3 cases represented by, well, at the beginning with predicates and at the end with a wildcard. If you want to ask what this dollar brackets means, this is just a static function, okay, representing some type for wildcards. So don't get scared with this. Also, if you are wondering why those weird case and match keywords are there, those are all static functions somewhere deep inside. Obviously, you can also create, if you look at the first one is quite exhaustive. It means that it contains all possible cases that where object can be in. But in the second one, we are covering only two. Well, in this case, it's exhaustive too, but if you are creating, well, if you knew that you are not covering all possible cases, you can use an option and return, well, an option instead of a normal result. As you can see, we can use also, if you use this fancy $bracket sign, we can also specify particular objects and not using predicates. So we have, as you can see here, we have $1, which means that if the past I is an integer of 1, we will get return a string that says 1, and so on, and so on. But it gets more interesting, because the real destructuring pattern matching, you can create more advanced patterns. So for example, if you can see here, the first case, well, it's just a local date with fixed year, month, and a day. But in the second case, you can see that we have a local date with the fixed year, but you have two wildcards, as a month, as a day. And now if you look to the right, you can see that you have a lambda there that has a month as an input to the lambda function. So if you write your cases like this, with leveraging object structure, you can create crazy stuff like this. But there's one problem with that. The problem is that if you want to use that on your own object, you need to add another module, JavaSlang module, and pretty much generate patterns for it. So this can be pretty unhandy, okay? Because obviously this is not a language level support for this kind of stuff. If you want to, if you like this concept, definitely you should check languages like Scala. So another very interesting example, well, you don't need to use particular objects, you don't need to use predicates or destructured objects, but you can use, for example, types. Optional is implemented using two subtypes, some and none. So why not just use a case where, for example, optional is some or is none, okay? Works well. But usually in most cases we will be just using predicates. And those come packaged with JavaSlang. Well, so all basic predicates like is null, is not null, is in something, any of, all of, instance of, they are all predefined and ready to use. So you can create stuff like, sorry for that, stuff like this. Here's another more real life example where you have two cases. First they all represent basically handling of command line parameters. So here you have the first case, for example, age or help. And in this case, you can see that we associate an action, display help. And in the second, you have either v or version, and then you, well, display version. If you pass something that's not in there, well, don't do anything, because we have no idea what this is. And the other thing is that obviously you are not limited to using pattern matching as a standalone. You can combine it easily with other tools that you have from JavaSlang. So for example, when you use try or optional, why not, for example, use pattern matching for simplifying recovery from that recovery from exception that was underneath, or maybe for advanced mapping in optionals, or maybe in streams, or anywhere else. Well, there are multiple places where it's really nice plays well together to form a very fluent API. So basically, that would be all. This was a short overview of what you will be able to see in Vavr. Vavr, it's not only what you saw, it's not only a core. There's also, well, there are additional modules. The most popular one will probably Vavr Match, which allow you to create your own patterns. You have also property testing framework, Vavr Test. There's a Jackson module for all of those classes, and two experimental ones, Vavr JWT and some stuff for rendering. Yeah, community really wanted to make that, so it's super interesting. So generally, thank you very much. I hope you like that idea, you like that framework, and you will want to use it on your everyday basis. The super nice thing is this, that if you go to your boss and tell him, dude, I'm writing Scala from today because I want to, well, they will probably kick you out. And this you can bring, well, mostly to every project that has at least Java 8. So I hope you like that concept. Well, let me know. And now we have a few minutes for questions. Thank you very much.
Thank you. So any questions? Anybody?
I have a question about the Vavr roadmap. What is planned? What is missing from your point of view?
I'm quite up to date with the roadmap, and the main focus now is to release the JavaSlang 3. The whole idea is to release 3 when the Java 9 will be released. So this is the main focus over right now. The other thing is that I mentioned is Java collection views, which will enable, well, instead of repackaging JavaSlang collections into Java collections, we'll pretty much return Java interfaces that will delegate methods to the collections that are underneath. Another thing is the total simplification of the API, because if you explore the Vavr type hierarchy, it's super abstract. Okay, there are many different types that has different functions, and it can be problematic because in some cases you have you implement multiple interfaces and end up with methods that are duplicated. So those are the main things that the guys work on right now. So cleaning the API, preparation for Java 9, and collection views.
Thank you.
So is this framework production ready? I mean, how are the developers of this framework? Are there any big companies interested in this framework? Or are there any products running and written in this framework? Or it's just something like early days of Scala Z, when the future you can predict and you can rely on the framework because it could die in a year and stuff.
It's a very good question. JavaSlang actually was the development started way before Java 8 was released. Okay, the first version of JavaSlang was actually released when the day after Java 8, and since the time it's gaining more and more popularity, there are more people contributing, and it's growing. Definitely, especially right now. But yeah, it's on the market for like almost 4 years, and definitely production ready. More bigger libraries, frameworks like Spring and for example, AssertJ, they recognize the existence of the library and introduce it to their concept. For example, if you have Spring Data or Spring Web, you can use those classes, for example, well, in repositories of Spring Data. And we've been using this, well, in our company since like 4 or 3 years, and we didn't have any like problems on production, and there was like I know at least 3 projects over there. I know guys at Software Mill that went to production with this and never had any problems. We abandoned JavaSlang in one project, in a Kotlin project, because in Kotlin, well, there is not that much need for tools like this. Actually, it can be problematic somehow, because if you mix like Kotlin optional types with options from JavaSlang, you end up with objects being like optional in few multiple like dimensions, and this gets super uncomfortable. So definitely, yeah, it's production ready.
Okay, thank you. We have time for one more question. Anyone? Okay, thank you then for your speech. And I would also like to remind you to vote for the speaker in the RigaDevDays app. Thank you.